an interesting session. So I would not advise anybody to miss today's class, because from this point, you can determine if you want to continue with Java or if you want to give up. So it's at this point, because what we'll be talking about today are all very important to determine if there's a future in Java for any of us. So I would like us to we'll try to be fast and move as quickly as possible while I try to explain with my slides as usual, and we'll do some of the examples, and I'll try to explain some concepts, then I'll tell you what to do after the class. Okay, so I hope all of us have our environment ready, either your IntelliJ or you want to use the web environment, the rep.it. So I'm going to be sharing my screen now. This is done. Okay, if you cannot see my screen, please let me know. I'll move on to, let's do a quick revision. Remember the last time we met, we talked about some things like the control flow, the if-then structure. We talked about the operators, talked about some functions, and then we also talked about type conversion, how to convert from one data type to another. So today, I'm trying to get where we stopped. Okay, yes, we talked about this. Moved ahead, I talked about this. We talked about this, and then we stopped somewhere here. Lock statement. Okay, so let's just start from here. Okay, but let's look on IntelliJ and see where we stop. Please, if you can't see my screen, let me know. So this is what we're trying to do the last time. We're trying to talk about the logical operator, that if A is less than B, if this statement is true, it's going to execute this part of the code. And if the statement is false, it's going to execute this part of the code. So instead of telling it to print, we can simply say that, remember A and B are integers, so definitely this has to be int, lowercase, integer. And then we can move this out and just say that let's even print the values. Let's print the values and say here that if it is A is less than B, then A. If not, we have P. So this is the statement. We can then print the values out by saying maybe we should use printf for proper formatting. Let's say A equals to S. We'll put a comma and put our K. Then terminate it with this. Okay, does anybody understand what this percentage S stands for? Okay, it's a formatter, right? So that means that I want to format this variable as a string. So when it's outputting it, I want to format it as a string. If you want to format it as something else, as maybe decimal or so, you can use something else to do that. So that whenever you see this, it means that in this position, it's going to print this value. So that's what that means. You can find out more about that online. 1, 2, 3. So I don't do it. We can put the, let's say this. And I want to print 80. So we can see what would be printed as 80 at the end of the day, because 80 is what we are using as our variable here at this point. Okay, so we can quickly run this and check out what it's going to give out. I can also use this to separate. Okay, let's just run it before I use that escape method. My system is slow today. Okay, so if you notice, I'm using printf, which is like a print format that can allow me to specify a string path and also the value that I want to print. So because I'm not putting a new line escape character, everything is printing on the same line, and that is not what I want. So I can use the new line character to, or what people call carriage return, to move everything to a separate line. Let's see, this is it. It's not this sign. There's the other one. Yeah, this one. Okay, so this is the new line character, escape, what they call it now? I think it's the escape character. So it helps you to move and create a break, like in your HTML break line, to move to a new line. Okay, but that's not the reason why we're doing this. Why we're doing this is because we just wanted to test to see how this conditional statement works. So we are saying A, if A is less than B, we know that A is 10 and B is 5. So definitely A is less than B. A is greater than B. So for the fact that this statement is not true, B is what will be executed. Okay, Victor, yeah, you can go ahead.
Yeah. Yes, I just want you to copy and paste this on the chat so that we can have it instead of typing, so we can follow you with the explanation.
Yes, I will do that. Yeah. But if we followed last week, this is exactly where we stopped. So I try to maintain the code so that nothing changes.
Okay. Yeah, I know.
Yeah. So I'll put it here for everyone to see. Let's see. Yeah, so you can copy and paste that.
Thank you.
You're welcome. Okay, so that is how this works. So I'll partition my screen now so that we can follow our guide. Okay, so the logical operators are just talking about your and, your or, your exclusive or, and your negation. Okay, so in case you want to say if A is not equals to B, this is the not equals to, and you use it in conjunction with this. And the other ones are there if you want to do exclusive or negation. But if you want to say if A or B, do this. Sorry, I'm always missing where this thing is on my keyboard. Yes, if A or B, right? So that is your or, and your hand is yeah, this double one. It's your hand. So you can find out about that. We won't talk much about that. So I can move forward. We move on to which is this. Yes. Let's go on. Input in Java. I've talked about input. So let's look at loop today. So if you see the way I structured my application, I'm going to delete all this now because I don't need it anymore. And I can move this. I think I've given it out, so I can move it. So we are going to be starting with loop. Okay, so whatever code we write here, we'll be moving it to a function. As you have it, we created a lot of functions. So now I believe we all know how to create functions. So we'll be moving to a function so that we can still have them at the end of the day. So we have loop. So what is a loop, and how do we, or why do we use them? For example, if you want to perform an operation that is repetitive, okay, that you need to do the same thing or something that looks alike for more than once, you might need to use a loop. That is, you want to be moving, iterating one after the other. For example, your multiplication table. let's say you want to write a program that will generate a multiplication table. So you need, let's say for 5 times, you say 5 times 1, 5, 5 times 2, 10, blah, blah, blah. You want to do something like that, you can use a loop, or probably in an array where you have, let's say, an array of integer. Remember I told you that whenever you see this sign, this square bracket, they call it now, it means an array. So you have an array of integer, new int, this, I can say of 3 values, and I decide to add values into the array. Don't worry, we'll still get to array. Array is part of what we are doing today. So let's say I want to add to the first part, I want to add 10. 16. Please, if at any point in time you have questions, you can call me back. I would answer. But you may not worry much about this. I just want to add values. So now to print out everything in this array, and I need to use a loop. Okay, so that's one of the reasons why we use loop, and for so many other functions. So we'll be looking at different types of loop. So in this short training, we'll just be talking about 3 types: while loop, your for loop, and then the do while loop. We also have the for each loop. Okay, so we'll talk about that too. So how do you use a while loop, and what is a while loop? A while loop will always do what? It will check a condition at the start of your loop. Okay, and then once you check the conditions, if the condition is negative, it will not execute what is inside. But if the condition is positive, it will execute the whatever you put inside the code. For example, as given on the screen, they are trying to solve a factorial. We all know in mathematics how to find factorial. Example, factorial of 5, it will be 5 times 4 times 3 times 2 times 1. Okay, you don't times it by 0. You stop at 1, because once you go to 0, you know everything would disappear, so will turn to 0. So they use this as the example. We can just, if we have time, we can run it and see, or I can just copy and paste it for you guys to run. I don't think we need to do it here, but what we just want to test is how does a while loop work. So the syntax you need to understand is while, you put your condition, and you have this, your open and close braces. So the condition, once it's true, then it executes this statement that we are going to put in here. But if it's false, it will not execute it. So let's say, for example, int a is equals to 10. And I want to say that, or instead of doing int, let's use scanner. So we accept the input and say scanner new entry is equals to new scanner system dot in. Okay, so we have this. Say that new entry dot next int. Okay, so let's say a is equals to this. Or I can just assign it to integer directly. Okay. In IntelliJ, if you want to, let's say the way I did this, for example, let's say my line is not properly aligned and you want to format your document, you can just do Control K, Control D to format, sorry, Control Alt L, that's what I mean, not Control K, Control D. Control K, Control D is copying. Control Alt L to format your document for you. Okay, this is saying A is already declared in the scope. So let's use AP something. Sorry about the naming of my variables. So I believe we all understand what this is doing, because we are trying to accept an input. And so when we accept the input, we pass it to this variable. So I want to say that while AP is greater than or is not equals to let's say 0, then print print let us print a whatever the user has entered. Okay, so we can have something like this. So maybe we should do it this way. This will be an infinite loop because if the user should enter, let's say 5, it will print this, and it will just continue to print this every time. So because we only accepted the user to enter the value once, so this is not a good example. Let's think of something else. What we can do is we can move this into the code and just say while whatever input is not 0, or let's do something else. Let's say while what should I do now? Okay, let's say while a is less than 2. Okay, then inside here I can decide to do what? To change the value of whatever the person enters. I can say AP equals to AP minus 1. So I'll be reducing 1 from whatever the person enters. This is minus, not okay. So, and it will print it out again. So let's see what this will do. Okay, so now can somebody give me the short form to write this? Instead of doing AP is equals to AP minus 1, what is the short form? We talked about writing short forms for operators. Who can help me? I need the response now on this line. Are we here?
Yes.
Okay, Victor, you raised up your hand now. Is it now or before? Okay, can somebody help me? What's the short form? It's on the screen on the right-hand side. Who can see it? Oh, sorry, on the left-hand side. I will not continue until somebody tells me so I can know that you are following. Maybe I'm not using the right time, the right term. But I said instead of writing AP is equal to AP minus 1, there's another format to write this. Who can help me? Okay, let's not waste time. Nobody. So it is this minus equals to 1. Have we forgotten? So instead of doing AP, so what I'm trying to say is that somebody enters AP, let's say AP, he enters 4, right? So we check, is 4 less than 2? No. So because 4 is not less than 2, it does this. Oh, sorry, if 4 is less than 2, it's okay. While 4 is less than 2, do this. No. This is not right. So let's say I want to say while whatever the person enters is greater than 2. Okay, so let's say the person enters 4, and 4 definitely is greater than 2. It prints this out. After it prints this out, it reduces the 4 to 3 with this statement, and then it goes back again and prints what is left. Okay, so printing what is left, it will be 3. So it comes back and say 3 minus 1, it becomes 2. Okay, so when it's now going back up, it will check, is 2 greater than 2? No, then it will stop. That's what this is supposed to do. So instead of writing it like this, we can just write this point like this. They are going to do the same thing. Okay, so let's print this and see what will be printed on the screen. Let's run this. And if there's an error, it will throw the error on the screen. Oh, sorry, it's waiting for me to input something. Put a 4. Okay, can you see what happened now? Immediately I entered a 4, it printed 3, right? And then it checked. After it printed 3 here, it reduced 3 to what? 2. So it comes up here and check, is 2 greater than 2? No. So it stopped. That's why I didn't print anything anymore. So it just print 4 and 3. But if I do this, greater or equals to, let's see what will be printed. Are we following at all? I'm just using this example. This is not really where we are going today, but I really need to explain some of this. Can you see now? So what it's doing, maybe we should make it more interactive. Because it's looking like we are not following. So let's enter a number. This says enter a number, right? So I want to enter, let's say 5. Okay. So let's you guys know that we can debug, right? Debugging means that we want to go step by step to check how this operation is happening. I'll run it, finish now, then the next one I'll run will debug. So if I enter 5, AP becomes 5, right? So we check, is 5 greater than or equals to 2? If 5 is greater than or equals to 2, which is yes, true. So the statement says that if the condition is true, then it performs whatever is inside this curly bracket. Once it performs it once, it goes back up again to check. Okay, remember that when it's performing it, it will have reduced this to 4 because 5 is equal to 5 minus 1. That will give you 4. So that means AP will now be 4. So it will go up here and check, is 4 greater or equals to 2? If 4 is greater or equals to 2, it will still come inside there, print 4, and go back and reduce 4 from 4 to 3. And goes back, is 3 greater than or equals to 2? Yeah, it will print it. Reduce from 3 to 2, go back and say is 2 equals to 2? Yes, it will print the 2 and then it ends. So let's see how this happens. Run it. So our output will be 5, 4, 3, 2. So let's do debugging. This is how to debug. Just put your breakpoint here, okay? And instead of clicking this run, you click this thing that looks like a bug. That's what we call a debug. Okay, so we have 4 minutes more for this session to end. In case the meeting goes off, just try and click back on the previous link, and then you'll find me in the meeting again. All right, so let's click on debug. So to debug, please, I need a response. Are we here, or I'm just talking to myself?
Yeah,
We are with you.
okay.
We are with you.
I needed to know. Okay, so there's something called debugging. Sorry, like I said, we are just crashing the course. If you want to learn properly, this is not how to learn. We know how to teach properly, but because we just want to chunk out something so that you can go and develop yourself more, and that's why we are doing this. So as the things that are coming bit by bit, I'll try to be explaining them. So there's something called debugging. Debugging means that you want to really see how these codes work line by line, so that in case there's an error somewhere, you want to be able to catch the error and see it. Do you understand? So that's debugging. So we have an icon here for debugging. But before the application can stop somewhere, you need to put a breakpoint. And that is what I'm doing. I'll just move my mouse somewhere here before the line number and click, and a red appears. This is a breakpoint. So that means when the application or the compiler is executing, when it gets there, it stops. Then I'll need to press something for you to go ahead and move on. So that is what I want to do so that we can see how this works. So we do this. Okay, it has gotten to this place asking me enter a number. So I'll come down and just put 5. I press enter to continue. Then you see this place is highlighted in blue, right? So immediately this debugger appears for me. Okay, so it shows me all my variables and their values. Now it's telling me that AP is 5. This is what I'm concerned about. Okay, so to move line by line, I'll press this or I press F8 on my system. But this is the icon I'll be pressing here. Okay, so F8 will help me to move line by line. You see this blue line moving now. I press it. So now, if you check your console, it has printed 5 because it has passed this line, right? So AP is what? Go back to debugger, console debugger. So you can be checking both of them. So AP is what? 5. So it printed out 5. That's what we have to do. Now, once we leave this line that says AP is equal to AP minus 1, once we leave the line, it will turn AP to 4. Okay. So let's do that. We'll press next. Then you see that AP becomes 4 automatically. And in your console, it has not printed 4 because it has not come back to this line. So it went back up to check, is 4 greater than or equals to 2? The condition is true. 4 is greater than and is not equals to 2. So it will come back into this loop. Okay, so that's how you, that's why the program is, that's how the compiler is working. So it comes back here and it's supposed to print what? AP, which is the next value, which is 4. So we'll move ahead again. It has printed AP. You can see 4 is out here. When you check your debugger too, AP is now 4. Then when it gets to this line, it deducts the 1 from 4. What do we have after that? 3. AP becomes 3. It has not printed the 3 out yet. So it's going to check again before it prints. Is 3 greater than? This is still true. So you move on again. And it prints out the 3, which you can see right here. And the next one is that it's going to deduct from 3. 3 minus 1. You have what? 2. So AP becomes what? 2 right here. But it has not printed it out. So because we have AP as 2, it goes up to check, is 2 greater or equals to 2? Who can answer that? Is 2 greater than 2? No. But is 2 equals to 2?
Yes.
Yes. So that's why it will enter again. If I don't put this equals to, it might not enter. Okay. So now it will enter.